Okay, so we're going to go over the apple trees challenge from yesterday. And this challenge was meant as probably your first bigger dive into object-oriented programming. It was the first time, I think, you had two separate classes that were going to interact in some way, even if one was just going to hold on to instances of the other. And we had some tests that we needed to pass as well. So let's take a look at the test file first. And so we talked a little bit about unit tests the other week, and testing is just going to take a little bit of getting used to. One frustrating thing is, like, you're going to learn one test framework, and then you'll probably get to a job, and they'll be like, no, we use this other testing framework, right? So for our time here, we're going to use unit tests. So that's the one I want you to use. It's a built-in, like, testing library for Python. Python just ships with it. So that's why we're using it, and it's used out in the world as well. So the way that this is, and you'll see, like, if you go to another testing framework, it might be set up completely differently. So I don't want that to blow anybody's mind. But the way that this one is set up is it's class-based, right? So, and all we're doing when we have tests, let me actually be more general first. When we have tests, we want to do a few things always, no matter what the syntax is. First, we want to kind of like section off our tests, right? Are these tests for the apple tree? Are these tests for the apple? If I'm talking about like a bigger program, like, am I testing user sign up? Am I testing like a user's ability to post a blog, right? So I need to like section those things off, block those things off. And one way that unit test gives us to do that is by letting us wrap groups of tests in a class. That's all we're really doing here. It's just grouping our tests together, and we're using the class structure to do that. Cool? So these are validate apple tree class, right? And because we aren't going to talk about inheritance till tomorrow, but you notice right here in these parentheses, we're inheriting from something called unit test.test case, right? And all you need to know for right now is that's a bunch of functionality that we are importing into this class. So we can't see the code, but it's there. There's a bunch of extra code in there, right? And methods that we have access to. We'll go over that in detail tomorrow, right? But just know, like, unit test gives us a bunch of extra stuff for our class. So unit test knows that, like, if I create a function, I pass it self, as long as I start it with the word test, it will run it as a test for me. So when I run this file, I'll get all that much more helpful input than if I had just written like a bunch of if statements or whatever. So what is this? Is apple tree spec py, and let's go up here. And so we even passed the test. How the hell did that happen? All right. Anyway, I don't know. Maybe we'll have to look at it. They what?
Don't they say pass?
Say pass where?
In the file.
In the file? Oh, no. These aren't the tests. Ignore this. Ignore that. We're just looking at this file right here. That's the actual class. And pass in this case just means skip this method. Don't do anything with it. Okay. So, what was I just saying? Okay, so that's how we get all this helpful feedback. So we get specifically like what test failed, but also we get this message right here. When you age the tree, its age increases by 1, right? And you can see that that's what we put here in a string. And we use this special string syntax with 3. And I'm not 100% sure. I'm pretty sure we have to do that in order for this test thing to work. Maybe we can get away with 1 string. I don't know. I've always done it this way, so let's just do it this way. But now we know, like, this is like a feature of the unit tests. It knows if I run a function with test in the beginning, the first thing I'm going to see is kind of like a human readable description. The computer doesn't care, but a human readable description of what this test should do, right? So that's 1. Now, once there, we're just writing pretty much simple Python code, or simple a regular like vanilla Python code with a couple of extra functions that we get from unit test built in. But really, we're just writing Python, right? So on line 10, I'm not doing anything unit testy at all. On line 10, all I'm doing is a very Python thing where I'm assigning an instance of apple tree to a variable. I could do that in any function anywhere, right? As long as this file knows about apple tree. Make sense? So, what? Oh, go ahead, Christina.
Just for the triple quotation marks, it's just like if you were to write a long block of code instead of a short block with the just hashtag. So you could write, like, if you put the 3 quotation marks at the very bottom, then all of that would be.
Oh, right. Yeah. It would, like, because we talked about that, I think, yesterday too. Like, it's a way of we can format our string without having to do like /n or /whatever. I'm not really sure, but we're just doing one line here. So all I was saying is I'm not really sure why.
You don't need it.
You don't need to do 3?
Yeah.
Okay, then.
You would just then do the hashtag to make sure that's a comment.
Okay.
Like, that's a block of a comment. Like a block comment,
okay.
And then one's like just one single line of a comment.
Got it. Yep. So syntax-wise, no matter what, most tests are going to have some, whatever the framework, they're going to have some part where you're just writing in plain human-readable language. This is what the test is doing. But again, Python doesn't care about that. That's for humans. Then I'm just assigning a variable. And so when I write a test, I just want to think of, I want to test when you age the tree, its age increases. So really what I want to do is I just want to see if that functionality works. If I have a tree and I call whatever the function is to age the tree, which is .age, or is it what was it? Age tree or whatever. I want to know that that takes like the age of 1 up to the age of 2, or the age of 2 up to the age of 3. So then I just have to think out what is the logic for the code for that, right? So I make a tree, and then I'm just testing. So this assert equals, that's unit test. That's a special unit test function. And I'm just saying, hey, assert equal that tree that I just created, I want to know that it, when I first create it, its age is 0, right? Because it has not yet lived 1 year. Then then on line 12, I call age tree. Again, just a function from my class that I want to make sure works. But then I need to test that it works. So I do the assert equal one more time, and I say, oh, if I call tree.age now, after I have called line 12, I expect that the age has gone up by 1. Does that make sense? Is that helpful, Christina, for like how these tests are working? All the way through, it's the same kind of idea, right? Anytime you see the assert this equals this, that's like a unit test thing. And there are a ton of different assert methods that you can call. Assert equal is a pretty generic one. There's like assert true. There's like, you can assert if something is an array, is a list or a dictionary, you know, so you can think about like writing tests is its own kind of art. It's its own kind of skill, right? So you need to think about like, what is the best way? What do I really need to know? Here I needed to know that a number went up by 1. Sometimes I might need to know that function works, or to be really confident that it returned a certain data type, that it returned, that maybe it's given an array, and then I expect after the function runs, something is removed from that array. It can get pretty complicated. You can have long tests. But that's the basic idea, right? You're basically just running code, and it's in isolation too, right? So apple tree, I can make this apple tree, and it won't affect the apple tree I made in the other test. So I can test these things in isolation and make sure that just that one thing I want to know works. Are there any other questions about the test? I hope that was a little bit helpful. Yeah, go ahead, Chad.
So in the first one, we have assert equal apple tree .age. Does that mean that there has to be a property in the method
with age?
Called age?
Yep. Yeah, or yes, it has to. I have to be able to call apple tree.age, or that won't. Yeah, that won't run. So the tests are like kind of already telling us, like, so you can see like just by looking at these tests, if we were doing like real TDD, test-driven development, if I had written these tests are already telling me a lot of the code I need to write, just like Chad said. I know for sure I have to have an attribute called age, right? I know that there definitely needs to be a function or a method called age tree. And then at the very least, we're going to find out it does more, right? But at the very least, it increases that age, right? So actually, just by looking at this test, I can already jump over to my code, and we can write some code right away. We could say self.age equals, and I look by the test that it expects the age to start at 0, equals 0. Then let's do age tree, and let's just say self.age plus equals 1. Cool? So now if I run this, I'm expecting, I won't pass all my tests, but I should pass this first test, right? Let's go down here, clear that. And you can see I passed that first test. Unit test isn't the best about giving you,
Where does it say pass?
it's just, okay, so you can see I have this dot here. You see that dot up at the top?
Yeah.
That's a passed test. E is an errored test. F is a failure. Dot is pass. E is error. F is failure. And error usually is also just means it fails. Or like it couldn't even find, because some of these functions we didn't even make yet. Cool. So what you want is all dots up at the top.
Got it.
Yep. Cool. So if we get like okay and then 5 dots or whatever, we win. Cool. Let's actually just do this until it's too agonizing and we can't do it anymore. We'll keep walking through the tests. See what we can do next. Okay, so age tree we did. Test age tree height. When you age the tree, its height increases. We have basically the same test here, right? Let's see. Or actually, this is a little different. So we create a tree. We save its height to a variable. We assert equal that the original height is 0. I wonder why that's done that way. Oh, okay. And then we say age tree. Then we age the tree, and we make sure that the new height is greater than the original height. And you see now we have this assert greater, which is just another unit test function. I'll, if it's not already in your curriculum, I'll post the doc link, or you could probably very easily Google it. But I'm sure it's just a huge list of assert equal things you can use, like functions you can use to test equality, so forth. So this is assert greater than. Cool. So this one makes sense. So I'm going to need a height. And that is going to start, let's just start it at 0, I guess. I don't know how you can ever try this here. And then this, I want to say self.height. We can just say plus equals 1 again. And now hopefully we pass that test. Scroll up to the top here. And now we have 2 dots. A failure, and error. Cool. Let's keep going. Sorry, this is so hard to read now. Oh. There we go. Okay. Do we skip one? When you call is dead, when you call the is dead method, it lets you know if the tree is dead. Okay, so there's a couple more things we need to write for this. So first, oh, well, actually, all we need to know is at what age is the tree dead? I think it says 100. I think this test is just overkill, but it says like at 100 in the thing spec, or I mean in the README. So let's just say return, and it just returns true if the tree is dead, right? Yes, assert true, right?
Yeah.
So I want to say return self.age true. So is greater than 100, right? So let's see if this passes. Cool. Did we pass that one?
No, wouldn't it have to be over 500 because it would be dead then?
Well, this is just saying set the tree age to 500, and if the tree age is greater than 100, which it will be here, it should return true. But hold on, when you call, no, maybe it did pass. Wait, you call, yeah, it passed.
I think that original height one.
When you call the pick apple method, so we have 2 that aren't working. When you call the pick apple method, it will return you an apple object. And when you call the any apple method, it lets you know there are any apples. So we didn't implement those yet. So we're passing the rest of them. Cool? We might have skipped one, did we? No. So so unit test has a couple of quirks that are a little annoying. One is, as far as I can tell, it runs the tests in alphabetical order, like after the word test, which is super annoying. So you can put like numbers in front of them or whatever, but it just does that. I don't know why. There might be some setting you can do to do that. So that's one reason why this is a little confusing. The other thing is a lot of testing frameworks will give you like colors to make this a little bit easier to read, and unit test doesn't have that. There might be like an add-on you can get for it, but that's also a little frustrating. It's not the best in that way, but it runs and functions well. Cool. So what's our next one? Any apples. Test any apples. When you call the any apple method, it lets you know if there are any apples on the tree. So we need to make a couple of decisions here. First, we need to hold apples on our tree, right? So I'm going to do that with an array. You could have done it in any way you wanted. Self.apples is going to be my array of apple objects. Let's see. Let's see if there are any apples in here. What is this test doing? It's making a tree. At first, it's testing. When I have a tree, there should be no apples on it, right? So it's testing that. Then it looks like it's I don't know, using some weird iter tool thing. And just aging the tree 10 times and then testing if they're apples. So another thing I'm learning from this is at age 10, it should add apples to the tree, right? So I want to do, I think that in my age tree, right? I need to do that. So I want to say like if if self.age greater than or equal to 10. Whoops. Then I want to, how many apples am I going to add? Let's just do, I think it's just a random amount probably, right? So let's import random for that. And then someone might have to help me remember the syntax for this. It would be like for I in range 1, 2. How do I get a random int?
Just beginning and an end.
Oh, why don't I just
use the random.
random.int rand int. Thank you.
And then that produces a range from
whatever.
Oh, so I don't need a range.
Yeah.
I don't need a range. Okay, cool. And I pass it two numbers like 1 and 10. Sure. This sad apple production. 10 a year. 10 a year. And then I want to do self dot bless you apples dot append an apple. And I have to import apples from apple. I think that'll work. Okay, cool. We clear on this code? We need to go over it again? No? Okay.
Why do you have to import apple?
So I have to, so that's a great question. I'm glad you asked it. So my apple actually exists in this other file, right? So I just got to import it. And actually it's doing basically nothing right now, but we'll get to that later. It'll still make the object. It'll just have absolutely no attributes. So.
I thought we were already in apple.
Oh, yeah. So we're in apple tree over here in apple tree spec. We're just working on our tree right now. Okay. And we're not using eyes, so I think we're supposed to do that. Cool.
Can you tell me why you did that?
The underscore?
Yeah.
Yeah, so it would still work like this.
Yeah.
But just a convention is if so in order to make my loop, I need to put something here. It's just letting other people reading my code know, hey, I had to assign this variable, but I'm never going to use it. So if you see an underscore over it, it's just like that variable is not getting used. It's just for
placeholder.
Sorry?
Placeholder?
Yeah, it's just not even a placeholder. It's just like because we're never going to use I in the loop, but I have to put something here. I can't write a loop. It won't let me do that. So it's just saying like, hey, I had to do this because that's how Python works, but I don't expect to see this get used. Okay, so now let's see if we passed this test. Where are we at now? Doesn't look like we did. No, okay, when you call the any, oh, that's because we didn't actually write the method anyApples. So anyApples is just gonna return self dot, nope, length, length self dot apples is greater than 0. Does that make sense?
Mm-hmm.
Okay. Now let's run it. Still did not pass. Call the anyApples method. It lets you know if there are any apples on the tree.
The length on the test, wouldn't you have to put like length over there for, even if it's just a random length of however many apples we're gonna have in the testing? That's what I was coming across, is that you'd have to put
I think you just have to do
I
I think we need to go back and look at what's happening with our Apple method.
Yeah, so I think this is not working.
Yeah.
Or wait, hold on. Int object is not iterable. This did not return a range. I think it returned an integer. So let's range and say 1 comma. That makes sense, I think. I don't know, man. I don't know how any of this shit works. Okay. All right, cool. We did it. Cool. So we're killing it, right? One test at a time. We're letting the test dictate the code we write. Not bad. Okay, so let's, what's my last one? It's the pick an apple. Test pick an apple. Oh, and then pick an apple error, which I think I fixed from yesterday. I know people were having problems with that one. When you call the pick an apple method, it will return you an apple object. So it looks like we're making a tree. Oh, sorry, we're making an apple, we're making a tree. Why are we making an apple? Oh, because we need to test that it's an apple object. So this is an interesting test here. So we're making an apple. We didn't really need to make it, but we did. And then we made an apple tree. Then we aged the tree 10 times so that it would produce apples. And then we are asserting that if I call pick apple, that the type equals the type of the apple. And so type is this thing. Have we seen type yet? Type is a nice little function that we have in Python. We can put anything inside of it and it will return. Is this a string, a list, a dictionary, etc. And it can be pretty helpful in a lot of, not just testing, but like when you're getting data back and you're trying to figure out why the hell something doesn't work. You use type a lot.
That was confusing. I was like, if it's a length, don't we need to put like length there and then length and apples? That's really cool that it do that for type.
Yeah,
so it would say same thing. Yeah,
so these are both going to return type apple because it's an apple class. So it'll even work for classes we create, right? Yeah. Yeah. Is that clear? Do you want me to go over that again? Okay. So that's what we're testing here. So let's just do the first part of that, which is I think we're just going to do, well, we can do both because there's the error as well. So we're going to say if self dot. So I could say if self dot apples dot, like, or if the length of the apples is greater than 0, then pick an apple. But I already wrote a function that tells me if I have any apples. So I want to use functions that I've written, right? So I can say if self dot any apples, and that's going to answer my question for me, right? If that returns true, then I want to return self dot apples dot pop, I think, is going to give me is going to remove the last thing. Okay. Otherwise, I want to raise the error. This might pass both tests. because the error is already. In fact, actually, that test is already passing, right? That's that last test. And I think that's why it was passing automatically. So should be good. There we go. Ran 6 tests. I got 6 dots, and I got a nice OK at the bottom. To make me feel real good about myself. Cool? Yeah, go ahead.
Actually, I passed on my test, but I did it really way different. Like, I think I was confused on the instructions. I got the test passed. But I just, like, for my apples on the tree, all it was an integer. And then when I, like, picked an apple from the tree, I just subtracted that integer by 1 and then created an apple object using that class.
That's how
that makes sense.
Okay. But Jake, I think is in this. He changed it because it wasn't working. So he moved it to like a string. And then, oh no, yeah, he put it into an array, and then kind of looks like this.
That makes sense for what we're doing now. Although, how did you do the diameters work? Because now we're going to go and give each apple a diameter, right? And then when we get into our runner file, which we haven't even done yet, we're going to have to go through the array of or pick. Oh no, because you're picking an apple, and I get it.
Yeah,
I get
picking an apple and it creates the object. There's a function inside the apple class that
that's fine. That would work for this. That would totally work for this. This idea, though, I want to make sure everybody's clear on this idea of like, because the today you're going to start a challenge that goes for the rest of the week. So you'll do it in pieces for the rest of the week and build out this larger program. And you're going to definitely encounter this idea of one class holding onto a giant array of other classes. And we want to get used to, like, because when we get to Django, we'll expand on that even more. Okay. So what you did is totally works. But this idea of like having an array of all these other classes is you're gonna keep seeing it. Okay. So let's see. We passed these. Let's. What time is it? Oh, cool. We're killing it. Let's do our apple real quick. I think there's some tests for our apple. And then we can look at our runner and finish that, and then we should be good for a break. So I'm going to open Apple and my Apple spec. There's only one test, so this should be quick. And the test is when you create an apple, it will have a diameter greater than 0. Cool. Self.diameter equals, let's just do random again. Import random. So, and here's a thing that we can think about, because sometimes you just want to pass the test, right? So if I wanted to pass this test, the easiest, simplest, least amount of code I could write to pass this test would be to do what right now? 1. Yeah, self.diameter equals 1. And if you did that, totally fine, right? Totally fine. But just for the fun of it, let's do random.randint 1 to 4. Sounds great. 4 to 6.
Yeah, because I was thinking inches.
Let's do 100 to 400. The biggest apples of all time. Okay. These are also so arbitrary numbers, right? Because it's like what? 1 inch, 1 centimeter, 1,000 feet. I don't know. Inch. Okay. So we just did that. So we should be able to pass our Apple spec. And we passed that test. Cool. So now we just need to go to our runner and take a look at, can we get the runner to pass? So let's go back over here.
In Python, do they always call it a runner?
It's not even a Python thing. We called it a runner when we were doing Ruby. I think it's just because we don't know what else to call it.
No, I kept seeing yesterday that they're called driver.
It could, yeah. There's probably a bunch of different names for a file like this, like the file you actually run to run your program. And we won't really, once we get into the frameworks, you won't see it. It's just like where we're at right now. Cool, let's walk through this real quick and see if we can figure out what it's doing. So we're importing the apple tree. Now we don't have to import apple because apple tree is importing it, right? I'm like 90% sure that's the case. Okay, so we're gonna make our apple tree. And then we're going to age it until it starts producing apples. So we're good on line 6. Then we're going to print some info about it. Then we're going to loop again until our tree dies. Oh, we didn't write any. There was no test for that. We have. Oh no, we did write is dead. I'm out of my mind. Forget it. I don't know what I'm talking about.
The part with the age right there, where did you get the age from? Like that it was over 100. It was greater than 100.
In that, so right here?
Yeah, self.age was greater than 100.
Yeah. Age is right here.
But isn't that 0 and that's not greater than 100?
Well, so this init runs once, right? We create a new tree. Init runs, and it creates all these variables and sets them to these values.
Yeah.
But when we call age tree, we increase age by 1.
Right.
We increase height by 1.
Right.
So these values will change.
Right.
Yes. So then when we call is dead, it will check age. Every time we call is dead, it'll check. And if it checks the first time and the tree has an age, it'll be 0. But then it'll check again and it'll be 1 and 2 and 3 every time we call every time we call age tree.
But wouldn't the age only be like 3 or 1 right now, just plus 1? If it were
Yeah.
at random 1 through 10 for the range, then the highest number right now could be say 10 or 11.
Well, so it's always going to age by 1, right? We're not doing anything here except adding apples, right?
Okay.
And actually, we also did forget to do. I think at some point it should stop growing height, and also it should stop growing. But forget it. We're not going to do that later. That would just be an if statement, right? If height this, then don't do that. Then don't age the height. What's up?
So I, for whatever reason, I wanted to see the is dead function.
Hey, sorry. Go ahead, Jim.
I kind of wanted to store that variable in the init. So something like
Store
dead equals or
right.
self.dead equals
False.
the result. Yeah.
Yeah.
So start it as false and then change it and update it every time you run it. Is there any kind of reason why you would or wouldn't do that?
That's a great question. So we could totally do self.dead equals false, right? We'll start at false.
Yeah.
Then when we're down here, we could actually, let me undo that. We could basically say if this then we would do self.dead equals true, right?
Yeah.
So a couple of reasons why we would want to do this, right? Now, this isn't checking, this isn't returning anything at this point, right? I could then say true, and then down here, did someone get messed up with my spacing? Yeah. Now I'm down here, and I'm going to do return self.dead, right? So it'll change it here and do here. One, I still have to calculate it each time, right? I still have to run line 19. So if there's a value, if there's something about your object that you need to calculate over and over and over again, then it's probably better to just write a method to do that for you rather than saving a variable that's kind of useless, right? Or that we're going to change and then return, but I have to make that calculation no matter what. Does that help a little bit? Yeah. So that's why I would rather do it the other way. You could do it that way, and it would totally work.
Wouldn't it have to be 101 for it to be dead? I guess that's where I'm checking that it would never be dead. It'd always be alive. So I'm checking if it is dead.
Well, yeah. So on 19.
Yeah,
Yeah, we're saying if the age if the age is over 100, then it's gonna die.
And in the test, it gave it 500 as
Yeah.
the age. Okay, that's what I
Yeah,
was
yeah,
trying
yeah.
to figure out how it pulled 500 for the test. If we never did a variable at top.
It's explicitly set in the test.
Down. Very good.
Here it resets self.age to 500.
That's what I wanted to make sure that I didn't miss there.
Yep.
Okay. Yeah.
No.
That definitely explain why.
These are good questions. Thank you for asking them. They're good questions. And it's super important that we understand how these classes work because it's going to be kind of the basis for everything we do. When we get to Django and you're confused as hell on coming back and just being like, I know how classes work, I know how variables work. Like it's going to look so different when we get to it, but the functionality is the same and it'll help you a lot if you can just remind yourself. So it's good that we have this. Go ahead, Bob.
Now, in age tree, you have self.age plus equal 1. Will that update the instance variable?
Yeah.
So what I was doing yesterday, I feel like I was doing the same thing. Self.radius. I mean, like I was trying to update the radius of like my apple every time it grows. Every time I age the tree, I would want to update the radius of the apple. But it's 2 separate files, so I created a function like in the apple py, and that function updates the radius of like my apple. So when age tree is called, also age apple is called.
Yeah, but you would have to call it on an instance of the apple. Like you can't just call it in another class. You would have to have an apple and then do dot change diameter. Because you were trying to like say like the apples are growing, right? Mm-hmm. Yeah. So you would have to do what I would. So okay. So right here where I have an instance of apple, I would have to on that instance.
Oh, put a
dot diameter bigger, like that.
Mm-hmm. Okay, I think I'm gonna come like a little later.
That's a good question. I think the stuff you do today will start to answer some of those questions for you and clarify some of that. Should we finish this? Let's see. Let's finish the runner real quick. Okay. So we we loop until the tree produces apples. Then we print some info about it. And then we enter this other loop where we have these nested loops. Our outer loop is going to keep looping until our tree dies. So basically, it'll loop 100 times, right? Then we have this outside variable that we're calling apple basket, which is just an array. And while our tree has any apples, if there are any apples, we're just going to basically pick that apple and put it in our apple basket, right? Now we got to do the diameter. So we need the average diameter so we can calculate that. Then we're going to print some more stuff, age the tree 1 year, and then loop again. So how do we do this diameter real quick? We want to, wait a minute, let me think about this. We need the total of all the diameters that are in the apple basket over the length, right? So, wait a minute. How did I do that? Can you just sum? No, you can't do that. We have to loop, right? So I have to do, so let's do it up here. We have to do a loop. For apple in apple basket, we're going to need a variable too. Total plus equals apple dot diameter. Cool. So these are instances of apple, which means I can access that random diameter I created, right? In my apple tree. Sorry, in my apple, all my apples that I make have a diameter that I randomly set. We good on that? So when we pick an apple from my tree, it's an instance of this class. And we put it in the basket here. Let's actually, hold on. Let's do, or let's finish this and then I'll do one more thing. Okay. So then I want to do diameter totals over length of apple basket, right? Okay, we'll run this and then I'm going to do one more thing. Y. What the hell is this called? Full tree. Oops. Nope. Tree runner, and it explodes. Average diameter. Can't divide by 0. Why is it doing that? Tree.pick any apple. Okay.
Could you just set the apple total to an empty variable or just put in 1 for right now?
Yeah, I think I maybe.
I don't remember making it.
You don't remember what?
Did we make a pick an apple where we actually pop an apple off and return it?
Yeah.
That apple's okay.
Pick an apple, returns self.apples.pop. And it passed the test too. So, apple basket, let's find out. Apple basket has an apple in it. So what the hell? Length apple basket. Am I just doing this in the wrong place? Yeah, I'll explain the embed in a second after figuring out what the hell is going on with this.
Because it's an empty array, is it possible that there are 0 apples in it?
Well, right now, at this point in the code, there is an apple in it.
But how do you know that based off of that reading?
So let's talk about embed real quick. I thought John went over this. My bad.
Sort of did, but
Okay. So IPython is just a bunch of tools. It's just pip install IPython. Just do it. You can do it globally, so you can use it everywhere. Gives you a bunch of tools. But the one that I use the most is a function called embed. An embed is like a debugger, right? You might have heard of the debugger in JavaScript. But what it will do is anywhere I put it in the code, it will pause the code, right? So Python code, at least the way we're dealing with it right now, runs synchronously. So it runs in order, right? Each line has to finish before we get to the next line. So anywhere I put embed, it will pause my program, and I will have access to any variables that are accessible in the scope that I put the embed in. And I will be able to I could go through certain iterations of the loop if I wanted to. This file is probably not the best file to do it because we have a ton of loops and stuff like that. But anywhere I put embed, it will pause. So where was I putting it here? So what I wanted to know was, let me tell you my thought process. From that error we got, it looked like it was trying to divide by 0, right? So it looked like length of apple basket was 0. So before it calculates this, I wanted to know, is there anything in my apple basket, right? So before I get to line 24. So actually, the first time I put anything in apple basket is here on line 18, right? Line 18, apple basket append, tree.pick apple. So if I put embed right here and call it, when I run this function, or when I run the file, it runs all the code up to line 19, and then it pauses, opens me up in, you know what this is this is basically a REPL. Remember when we were talking about the REPL? So I can run any Python code in here. 1 + 1, sweet, right? But it's a REPL that has my program in it, right? And had my program in it and paused at this moment. So paused at this moment, I would expect apple tree should equal an instance of apple tree. So let's check that out real quick. So remember I made a tree, instance of apple tree. So if I type tree in here, then I get my apple tree instance, right? If I do tree.apples, I get an array with all of these apple instances in it. Does everybody see that? Make sense? all these Apple objects in it. And remember, this is like, we don't need to know this really for any reason other than I'm saying it right now. But these are the addresses in memory. This is the type of object it is, right? So I get all that stuff. What I wanted to check was, so all that stuff is free to me. I can call anything, I can check that out. And I wanted to check Apple Basket. And that is an array, and it has an apple in it. So if I do length, Apple Basket, I get 1. You know what I think is happening? I think there's something wrong with my diameter now that I've done all this. Diameter total plus equals Apple diameter.
Started at 1.
You do Apple Basket, 1 and got diameter. Oh,
Because it's in the wild
Hold on.
apples loop already, you need the second loop, and you just have it have a diameter.
You're right, I probably don't.
And keep it count.
Name diameter total is not
Well, I don't know why.
diameters. I can't believe we're having this much trouble with this. So diameters total is 0. Oh wait, that's what I would expect. That's what I would expect. So let's do this. Let's get rid of this. Do go away. Okay. Let's try this. Let's exit and let's embed right here. Oh.
That diameter, is that like, I know it's singular, but can we write something that gets the diameter totals?
So hold on. Does anybody see it? It's got to be so obvious. No, 1/16. I hate it.
Is that equal?
I'm so pissed.
Apples dot average diameter? Like needs to be put up there?
Apples dot average diameter. Let's run it one more time and take a look at the error. Okay. So apple tree runner on line 23, which is this, diameter total over length of apples. Oh, is this happening because, no, we should have apples at that point.
But
Where's dot diameter right there? Like,
That's on the apple object. That's this.
how are we killing the tree? Is there a chance that we're killing the tree before it's checking, and that there's not apples in the one later?
that while loop stops right before it goes.
Yeah.
I thought so.
Is tree dead? Done. Oh, because it did print. Look. Oh, see, I missed this. See, read your freaking terminal, Josh. Okay, so this is interesting. So it ran. You know what? There's probably a flaw in our is dead. Maybe that's the problem. Maybe this is. Maybe we need that. Just a guess. Nope. Hold on. What? Go ahead, Karen.
In Apple tree file, I think we created a case where Apple chapter, like in the when you use random rounding,
Yes.
because you use range from 1 to random 1 to 10. If we like use 1, like, range from 1 to 1.
Oh.
And then,
Oh.
Genius. Yes. Nice job. All right, sweet. Hey, that's the game. That's the game. So step up to the plate or go home. That's all it ever is, man. Off by 1. Nice job. Thank you. Thank you. I would have never, ever caught that. I was about to give up. Okay, cool. So we did this. Are there any other questions on this? I hope this was a little bit helpful and illuminating. Cool. All All right, let's take 15 minutes. We'll take a 15-minute break, come back, and we'll talk about databases.
Last one.
I don't know.
Just one.